Professor Lilienthal, could you explain your project in a few sentences, please, to our audience?
Yes, I can. So ILIAD is about flexible and scalable automation for fleets of forklifts, especially forklifts, for fleets of autonomous vehicles. So it will actually contribute directly to the domain of intralogistics, but it has an impact, or we believe it will have an impact, of course, far beyond. Wherever you have multiple vehicles in environments that are dynamic. So the special characteristics of the project are that we consider the whole fleet from the very low levels of concerning controllers and safety up to the very high levels where we integrate coordination, task, scheduling and motion planning. And we have especially in mind SMEs, companies that actually want to react to the increasing needs of the market, faster product cycles and unpredictable trends. And they want to react to this by increasing the level of automation. However, the investment for a fully automated warehouse cannot be made, or the types of goods that are to be handled do not lend themselves for full automation.
So you are interested in finding solutions for warehouses with maybe changing objects, and maybe some are in large quantities, some are not, and you need to be very flexible with your transportation system and your logistics system.
Exactly.
So you have a fleet, as I understand.
We have a fleet, yes,
so
yes.
they are not. They should not collide. They
should not collide. They should actually optimize the way the efficiency while they are working. They should support in their deployment. And as you said, it's we are developing technologies to be integrated into existing warehouses.
So does this include the whole IT structure of the warehouse? Or?
Not the whole IT structure. So what we assume is that we get rough indications of what needs to be done. Like we need to pick up these particular goods and then bring them in pallets, like reorder them in pallets and then bring them, for example, to a loader.
Yes.
And we are particularly collaborating with companies in the food distribution sector. So there is, I hope I pronounce this correctly, Asda in the UK, and there is a Swedish partner, Orkla Foods, and they are in the food distribution sector, and the orders there really depend on unforeseeable factors.
Okay.
So they may change very quickly, and the system has to react to that.
So your robots or your let's say autonomous forklifts,
yes.
Do they have an eye, a camera to see what goods they are picking? So they are, because the warehouse may be somewhat, shelves may have been shifted for a while.
Yes.
Or so.
So they always monitor the environment with laser scanners, cameras, and they will learn by themselves, for example, patterns of activity, so that they can say, well, in this area, it is very likely that at a certain time there will be a traffic jam, so I take that into account and I don't go there. They will also, when you bring them into the system, we want to ease deployment. So when you just start them, and then they go around and find repetitive structures, try from the inventory database, try to label them, so try to find the goods by themselves, and if they can't, then they just tell the operator and then they have to label.
Your project just has started.
Yeah.
And when do you expect first results in a warehouse, for example?
So that really depends on the parts we are working on. So regarding the forklifts system itself, we are already working in Swedish projects for a long time. And there we have a direct exploitation with our partner Kolmorgen. So they implement and use a lot of our results more or less directly.
And they don't have any problems using academic software?
No. Well, they want to re-implement it themselves, from what I understand. But this might be also in order to understand it better and so on. But then we also have developments in the project which are newer to us. So we will have, for example, a systematic investigation of safety. So we will make studies of forklifts colliding with crash test dummies, and from that we build a database, an injury database, which will then be taken account into motion planning.
Yes.
So the forklift would see, okay, well now I cannot avoid a collision, then I do it at least in a way that is least harmful for people.
I understand you have many facets in your project.
Exactly, and there the results will be a bit later.
Okay.
And we also work on manipulation, so the robots should unwrap the pallets and then pick the goods.
So,
and,
yes.
Yeah.
Very complex.
It is. Yeah.
So there's an opportunity now for a message to the robotics audience. Are you interested in more exploitation or in cooperation with other projects? What do you suggest for Europe? What is your suggestion also from your own work in the past?
So I believe that actually the approach that we have taken, which is very modular, and allows companies to keep parts of the whole system, which they have and want to keep for legacy reasons, that this approach is very valuable in order to introduce robotics. Mm-hmm. And then, of course, a second message is that autonomous driving is a long shot, and the way and the environment that we have allows to do a shorter shot here.
Yes.
Because in some ways we can control the environment, so it's semi-controllable, and the speeds are lower, but still the problem is very hard, very challenging, and the solutions then, of course, can contribute to generally applicable safety standards, for example.
Yes, I realize. So, thank you very much. Good luck with your project,
You're
Professor
welcome.
Lilienthal.
Yeah.